Alrighty, question 10. After a very intense algebra bootcamp in question 9, let's start off section B with a relatively easier question. This question is on binomial distribution. I'm so nice I even included it in the name in the question part. So let's start with part A. What are the assumptions? 1. The probability of having a flawed cookie is constant. Secondly, the event of a cookie is flawed is independent of the event that another cookie is flawed. Part B. Given that P of C less than or equal to 11 is 0.15, find the value of P. Well, theoretically, you can solve this question using GDC. However, you don't know your P yet. We know P of C less than or equal to 1 is 0.15. This means that we have either no flawed cookie or one flawed cookie. No flaw, one flawed. No flawed cookies whatsoever. That's 1 minus P to the power of 20. One flawed cookie out of the batch. That's 20 chooses 1. P times 1 minus P to the 19 is 0.15. And here we can solve the equation using your GDC. So P should be equal to 0.159. Part C. 10 boxes of cookies are randomly chosen. A box will be accepted if it contains fewer than 4 flawed cookies. Find the probability that there are at least 2, but no more than 5. So, we know the probability that a cookie is flawed, but we don't know yet the probability that a box is rejected. So we have to find that. P of box rejected. We know that a box is rejected if it contains if it contains more than or equal to 4 flawed cookies. So let X be the number of flawed cookies in a box of 20 cookies. So X is binomial 20.08. P rejected. This is P of X less than 4. So P of X less than 4 is equal to 0.92938. You are going to use your binom CDF because we are using the cumulative version of it. Now, we want to find the number of boxes rejected. So this will be another binomial distribution. There's a total of 10 boxes, and the probability that the box is rejected is 1 minus this probability over here. Therefore, the probability that y is between 2 and 5 is 0.1588. Part D. We have a random sample of 15 boxes of cookies. 3 of the boxes are found to be rejected. Find the probability that the third rejected box occurs on the 15th box. So, for this part of the question, it helps to sketch. a very tiny picture. So those are your 15 boxes, 5, 10, 15. We know there are 3 rejected boxes in total. So there are 3 X's. For the probability that the third X is on the 15th box. If one of the X's is here, that means that for the remaining 14, you will have 2 X's in total. So the probability that the third rejected is the 15, is the probability that having 2 rejected boxes in the first 14 times the probability that this box is rejected, which is 0.070615, divided by the probability that 3 of the 15 boxes rejected. So here, so far, is plain language. Now we are going to convert this to math. 2 of the 14 boxes are rejected. This is 14 chooses 2, probability of rejected, squared, and this guy to the 12 times this probability divided by 15 chooses 3, P of rejected, cube, P of not rejected. And you will get 0.2 because they conveniently cancels out. They also cancel out. So